Hello. Okay, we're live. Let's go, Leetcode. Number 151, reverse words in a string. Medium. Given an input string S, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Return a string of the words in reverse order concatenated by a single space. Note that S may contain leading or trailing spaces or multiple spaces between two words. The return string should only have a single space separating the words. Do not include any extra spaces. All right, so Python has a string method called split. We're gonna not use that just in case that's cheating. So we're going to create a list of words. So words equals list, and then we're gonna have our current word, which will be empty string. For character in S, if character is not a space, then we append it to word. Word plus equals character. Otherwise, we add word to words. Words.append word. Which means if there's duplicates, okay, so word gets reset back to this, and only if there's a word do we append it to word. Then at the end, we just return our list of words joined together by a single space. And I totally forgot the part about reversing, so you know, we could just do this to iterate over the words backwards and then join them. Is sky the? I missed the first word. Oh, because at the end, if I have a word left over, I still have to add that. The way I could do that is by just adding in a space to the end of the word. That way my regular logic handles it. Okay. I'm a little wary that this counts as cheating, but it would be so easy to fix. You just iterate over the words backwards. So I think that this works. Okay. How can you beat that, huh? Next problem. (152) maximum product subarray, medium. Given an integer array nums, find a subarray. A subarray is a contiguous non-empty sequence of elements within an array that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. Okay, so immediately I'm thinking of an n cubed idea, which is for every, actually this is an n squared idea. No, this is an n cubed idea to start. For every pair of start/end points, calculate the product. The reason it's n cubed is that you have an outer loop for the start point, an inner loop for the end point, so we're at n squared now, and then calculating the product is n, so overall we do n cubed. So there's a immediate improvement that brings you to n squared, which is to do the same as above, but remember the intermediate values of the products, so that as we're iterating over the next element, we're only ever adding we're only doing one extra work to add one extra number to our list. So that's n squared. Can you do better than that? Possibly. How would you do better than that? So honestly, the fact that this is rated as medium makes me skeptical that you can do better than that. Which is not exactly a fair way to figure that out. So let's think about it for another minute. How could you do better than trying the start and end point? You'd have to do some kind of pre-processing so that from every start point you can immediately figure out what the end point is, or something along those lines. You'd have to be able to quickly jump to where's the end point. So here's some interesting things to observe, I guess. It's an integer array. So the only thing that's going to make your product smaller is negative numbers and numbers and zeros. So non-positive numbers are the only things that'll make it smaller. So you always want to consume everything to the right of your number. You know, if you're considering a start point, you always want to jump ahead to the first negative numbers. What else can I say? You never want a zero. So zero will always separate solutions. Like if you have a zero, that means your only candidates are on the left of the zero and on the right of the zero, but they never include the zero. If you have negative numbers, you have to grab them in pairs. You have to grab them in pairs. So if I have like a list of numbers, then This is a weird thought, but I could consider two separate lists. One where I pair them up. I'm not sure how to talk about the pairs. Okay, I think I have an idea here. So from each point in the list, if this is my start point, so yeah, for each start point, I know where the end point is going to be. That gives me the biggest value. It is the point that comes after this, such that we have an even number of negatives and no zeros. So we would want to jump to right here. And then once we've figured that out, so we can figure, starting from the first point, we can figure this out in O of n, because you just go forwards until you get to a 0, or you ended on a odd number of negative ones, and then you go backwards until you get to the first point that isn't like that. Once we have this endpoint, we know that's going to be the same endpoint for every number here up until we get to the end of the list or the first negative number, whatever comes first. So each incrementing of the start pointer is O1. Until we get to a negative number. Then we have to expand right if there was more negative numbers on the right, and left if there wasn't. This is getting hard to analyze, but I think it's O of n. The thing that makes it hard to analyze is I wonder if you need to consider the amortized analysis, because it's like most of the time you're just going forwards by 1 and not doing anything else. Sometimes, like after a 0, you have to go forwards by n, but then when you do, you save that work, and then you keep iterating forwards through those n's for the next n. So going up to a 0 is O of 1 amortized, because you save that work until you get your start pointer all the way to there. The negative 1s are a little harder to think about. So you move backwards from the list. So you could remember where the forwards negative 1 is. And you could remember where the backwards negative 1 is. And I think you'll just be jumping between these two as you iterate over other negative 1s on the start side. Yeah. Okay. So here is an O1 answer. For every start point. So that's, sorry, this is not O1, this is ON. For every start point, and that the for every start point takes ON time. Iterate endpoint forwards until you get to a 0. That's O1 amortized. I don't like the new lines here. Remember last and before last negative number. And yeah, then when incrementing start point, we can jump directly to endpoint. Okay, so for start in, and I think we are going to need and then actually, all right, so let's do it the stupid way first. That's going to take n squared, and then but is going to be easier to reason about, and then after that we can fix it by remembering the intermediate products. Remember intermediate products. So for I and start in range of, or in enumerate nums. You know what? I don't even need start. For I in range of len of nums. For j, why don't I call it start and end? For end in range of start up to len of nums. Right now, I guess I'm writing the n squared one. We're gonna adapt it to be the on one. Best equals 0. I mean, negative infinity from math import infinity. If best or best equals max of best and nums from start to end, product of that. So I don't think there's a thing just called product. Yeah, so like there is for some, but I can do from operations import product. I think. Let's test that. Python from operations import product. No. From operation from operators. What is this module called? From operator. It is called operator, but it's not called product. Mult? Mull. No, it's not called mull. Or it is called mull. Okay, from there we go. From operator import mull. Here we're going to reduce mull on our list of numbers. So just put that in a new line to make it easier to read. Product is reducing mull on the list of numbers. Return best. So this is the n squared. It should give us the right answer, but not be fast enough. How is this not valid syntax? What am I... What is wrong with the syntax? Oh, I have in twice. Paris in the springtime. Reduce of empty iterable with no initial value. Okay, the initial value is 1. Although I guess it shouldn't be 1. I guess we should just not have empty iterables in our list here. So why don't you start start at start plus 1 or end at start plus 1. Okay, it gives the right answer. It's going to be n squared. We're trying to do n. You know what? Actually, the way I wrote this is the n cubed version. But we're going to bring it down to n. So how do we do that? For every start point, we iterate forwards until we get to a 0. So while, or let's do end equals start plus 1. While nums of end is not equal to 0, end plus equals 1. Or wait, I don't want to, I do want to do that. Let's save this answer as the n cubed answer. And now let's write this down. You know what, while we're here, let's write the n squared answer, which is the same, but you remember the intermediate products. So product equals nums of start. And then as you add numbers, you multiply your product into them. So product times equals nums of end. Yeah, so this should be n squared, because inside the inner loop we're only doing O1 stuff. We're just doing one multiplication. So that's n squared. And now on to our complicated answer, which I will start with the n squared one to as our base. Okay. So what you want to do is, while end is not equal to 0, end plus equals 1, while nums of end is not equal to 0, start end at end equals start plus 1, and also and len, this one should come first to prevent index out of bounds exception. End is less than or equal to, or just less than len of nums. Okay. So this just says go until the next 0. Yeah, go until the next 0. While we're going, there's a few things we're looking for. We want the before last negative, and we want the last negative. There may not be any negatives, so we have to start these at none. If nums of end is less than 0, then before last negative equals last negative, and last negative equals nums of end. Oh, I just want to remember the index. I just want the index. Okay, so at the end of this, I'll have the last negative and the before last negative. Which tells us where we should jump to. So this, yeah. Okay, so for each start point, we've found the end point. We should keep track of the product as we're moving this pointer forwards. So, okay, so we've got product here as we're moving the pointer forwards. We should keep track of the product. So product times equals nums of end. So now we've got this up to this. Best equals max of best and product. So we've got this. No. We don't have that because we're going up to the 0. So we didn't keep track of the parity, the number of negative numbers. So parity equals 0. So that's how many negative numbers we have. And then as we go, every time a number is negative, parity equals excuse me, parity plus 1 mod 2. So so we know if the product's going to be positive or negative at the end. This is the same as doing an XOR on the parity. Let me just peek at Python. How do you, let's say A equals false, A false. I think this symbol is XOR. True, true. Okay, so if I do A hat equals 1, A hat equals 1. Okay, so hat equals 1. Nope. Because I would expect 0 hat 0 should be true. Oh no, I guess that is false. Okay, so that is how you do an XOR. So instead of doing this, I can do hat equals 1. If I keep XORing every time, I'm switching this between 0 and 1, which is going to tell me the parity at the end. And the parity tells me if my overall number is going to be positive or negative. Okay. So we do all this. Which brings us to here. Nope, it still brings us all the way up to here. And we know the parity. If the parity is 0, then we can just take the product from all the way out here. If the parity is 1, we have to jump back to before the last negative. So we would go to last neg minus 1. The other confusing thing here is I don't want to do all this work for every start point. So we need to remember end out here. We need to say while start is less than len of nums. All the way out here, we increment start. And then this stuff of figuring out the new endpoint, we only do it if we need to. So if start has passed end, if end is less than start, then you do this. So this takes O of n on any given iteration, but it's O of 1 amortized, because every time you do it, you don't have to do it for the next n. Okay, and now there's a bunch of points we need to jump between. So we start here, we end here. If our parity is 0, if parity is 0, then the product right now is, this is so hard to think about. Because then the product, because the thing is, what we're going to be having to do is like divide by the thing at the front of the list in order to keep product going, because this is really a 2-pointer solution, right? Where we sometimes increment the right pointer, sometimes increment the left pointer. The only problem is the right pointer is going to be jumping back and forth between a few different endpoints. And whenever we do that, we have to remember how much we should be multiplying by as we jump between those things. So I may have written this in a confusing way. Also, I don't think we need the before last negative, right? You would never want to jump to the before last negative. You would either want to be right before the last negative or on the last negative. So I think that simplifies this a little bit. It's not that you'd want to be, yeah, you'd rather either be right before the last negative or right before the last 0. That's what I mean. Because you'd want to consume the stuff after the last negative if it's helpful. Okay. So I think I've confused myself a little bit here. I'm going to comment this out for a minute and see if I can rewrite this in a less confusing way. Because I want to think of this as a 2-pointer solution. You're either incrementing the left or the right. No, because I want to, well, yes, no. The thing is, that's going to be too slow if I have to jump, because I need to be able to jump between the 2 possible endpoints So I can't think of it as either increment left or right. Well, I can actually, because I can just say if I've incremented left and I just got rid of a negative number, then jump. What I can't do is increment by 1 each time I try to go between the two endpoints. Because there might be n elements between the two possible endpoints, and I might have to be going back and forth between them a lot. So the fact that I have to jump between two possible endpoints is making this hard to think about. Let's bring this back. Let's start by just finding. Okay, let's start by just finding the two possible endpoints. So if we've got end 1 and end 2. And we have start end 1 end 2 equals 0, 0, 0. If end 2 is less than start, why don't we say if end 1 is less than start? Then we find the new end 1, end 2. Let's just find them separately. It'll be easier to do, and it'll be the same runtime asymptotically. So if end 1 is less than start, find the new end 1, which means increment until it's not just until it's not less than 1, but increment started at start plus 1, and then while end 1 is not equal to 0. I guess it's easier to find end 2 and then go backwards. It is, because end 1, here, let me add these. End 1 means before the last negative. End 2 means before the last 0. So end 2 just goes until nums, or right, while nums of end 2 is not equal to 0. End 2 increment. And then end 1 is you then iterate backwards to find where end 1 was. Which means you go backwards to find the first negative number. End1 equals end2 while nums of end1 is greater, we know it's not going to be equal to 0. So while it's greater than 0, end1 minus equals 1. Which means it'll end on the negative. So we want to go one more than that. End1 minus equals 1. I just want to write this stuff down. So end1, end2 is the last index before a 0, and 1 is the last index before a -1 before a 0. Before a negative number before a 0. So now we kind of know end1 and end2. I have to consider the edge cases now. So while end2 is less than len of nums, so end2 might be the end of the list, not a 0. What if there is no negative number? Then end1 might go beyond start, so we don't want to do that. While end1 is greater than start, you do that. And then at the end, if end1 is less than start, end1 equals none. So maybe there is no, maybe there is only one product starting from this start point. Okay. This should be less than or equal once you're on start. No, you know what? It can be less than. Okay. So now we've found our start and end point. No, this should, I can't tell if that should be greater or equal or just equal. Okay, we found our start and end point. We're only going to have to redo this whenever our start goes past a certain point. So now we can just do stuff, assuming that we just incremented start. No, we have to, here we just, okay, we have to finish doing our pre-processing for when we have just incremented the endpoints. So now we have product 1 and product 2. Product 1 equals nums of start. They both are. Product 2 here, let's do them one at a time. Product 1 starts at nums of start. And then we can actually just do product 1 equals nums from start to end 1 and reduce mul of this, and product 2 is this. This is allowed because we're allowed to do on work inside this if. One of these will be positive, one of these will be negative. I don't actually have to worry about which one's which. I could just give me whichever one is max. So best equals max of best, product 1 and product 2. Can you take 3 things inside a max? Python max of 1, 2, 3. Yes. Okay, then the other case is that we have to increment start. So to increment start, you just do start plus equals 1. And then you product 1 remove nums of the number that you just removed. So let's increment start after we're done. And product 2 as well. So now this is the easy case. Incrementing start, we just divide out the number that we are removing from our running product. Dividing, because these are integers, this will never give a larger number. So I don't even have to take the max here. And in fact, I don't even have to consider these. It doesn't make it slower, but it might make it simpler to come back to this and think about how well, yeah, why don't we just say, okay, actually, what happens if you are if you increment past end 1, but if you're between end 1 and end 2, I don't think I've handled that. Okay, so at the start of the loop, Oh, also, I can't, this needs to start out here, I think. And there's no such thing as product, there's just product 1 and product 2. Okay, so inside each loop, I'm incrementing something. So if my end 2 was less than my start, then I figured out a new end 1 and end 2. Actually, I did say that end 1 might be none. So I think I need to do if end 1 is not done, then you do this. Else product 1 is 0. And end 2 can't be none. I know this is getting more complicated than it needs to be. I'm starting to get a vision for how this should be simpler. It's just the end 1 is making stuff a little complicated. Call it negative infinity instead of 0. So what happens if my start point has crossed my end 1 point? Then I don't want there to be any more end 1s. So if start is greater than end 1, product 1 is 0, and then it's going to be, or negative infinity, whatever. So then we won't be considering product 1 anymore. Let's get rid of this. Let's try running it to start finding some errors. While end 1 is greater than start, how can the list index get out of range if I'm incrementing downwards, like decrementing? And I'm staying bounded by start. I'm starting at end 2 and I'm going left. Print start end 1 end 2. So it already started. Start is 1, end 1 is 4, end 2 is 4. I'm only printing once. So immediately it's saying, oh, because this needs to be -1, because I don't actually want to reach len of nums. Okay. Reduce of empty iterable with no initial value. That means start and end one are the same. But I don't want that. I want end one to be to the right of start. +1. I'm thinking I might need to add a +2 though. Okay, print start end 1 end 2. One, 1, 3. So start and end are the same. Start and end 1 are the same. I don't want that. I want it to start at least one further. I have to do the extra -1 because I want to start before the last negative number. So that means I have to bound it at start +2. So that once I do the -1, I'm at start +1. But that didn't work. How? Oh, is that because it was already... Oh, I guess, what if there is no negative number? Oh, I also need that this is +1. Actually, this is all I need. This I can keep the way it was. Right, end 1 doesn't necessarily exist. If end 1 is none or start greater than end 1. Division by 0. That makes sense. We should skip over the zeros. So instead of incrementing by 1, while nums of start is not equal to 0, or like I want to include 0 as a best, but I also want to skip over the zeros. So I guess what I want is an if nums of start equals 0, then best equals max of best and 0, start plus equals 1. Print me start end 1 and 2 right here. 2, 3, 3. While end1 is greater than start, which it is not. Yes, it is. It is greater. And nums of end1 is greater than 0. Oh, how did we get to 3? We're supposed to be bounded by the length of the list. Oh. This needs to be -2 because we add an extra 1 once we get there. How are we getting an end2 that is greater than the length if I'm doing this length thing? Oh, because it probably starts greater than the length. What do you do in that case? I guess you only increment the end what do you do in that case? I think actually I'm just missing this -1 here. Okay. Well, we stopped returning errors. This is the right answer. Obviously, the best answer here is 2 times 3, and we said the best answer is 3. So if we print at every point what our start and end1 and end2 are, we start at 0, 0, 0. Okay, so that this needs to be less than or equal so that when they are equal, we increment end. Okay, that gives the right answer. Let's come up with our own test case because it should be easy to do. So I have a bunch of 2's. I have a 0 right before the end, and I have a -2 right here. Um, 0, 1, 2, 3, 4, 5, 6, 7. So 7 and 8 are supposed to be my end1 and my end2, but I'm finding 8 and 9. Like, print nums of end1, or don't print, you're already printing. Nums of end1, nums of end2. Or no, actually, wait, why did this fail? List indices must be, oh, because they can be none. Actually, I think 8 and 9 is right because I'm slicing like this, and this doesn't include the number end 1. So I think that is right. It's just that 0, like multiplying this. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So slicing from 0 to 9 will give you end 2. Slicing from 0 to 8 I guess I said I wanted the number before the last negative number. So my end 1 is not small enough here. I do think this should be 7 and this should be 9. Because I want one index to be here and the other index to be here, so that when we slice at it, we get the number before this, and when we slice at this, we get the number before this. So end 1 is not small enough. End 1 starts at end 2. While end 1 is greater than start, and the number at end 1 is positive, then decrement it, because I want to end on a number that's negative. And then I don't want, I actually do want to end on the negative number, so I don't want to do that. But now I'm going to have an even bigger number, and I was trying to get an even smaller number. I'm ending on 9, 9. Why? Because start is 0, while end 1 is greater than start, so I should just keep going. And, oh, nums of end 1 is going to start at 0. If I start 1 before end 2, then I should get the right number. And I do. Okay. One more test case. If I have 2 negatives here, then I want to be ending at end 2 instead of end 1 for a while. That's giving the right numbers, so let's submit. What do we do on just -2? So start is 0, end 1 and end 2 are 0. We'll try to move end 2 to the end, but it'll end up staying on the same place as start. Do we just need to have a if len of nums equals 1, return nums of 0? This one we should be able to actually handle. So what are we doing wrong here? Print start end 1 end 2. This doesn't look right. We're supposed, so end 2 should be here. Actually, end 2 should be at the end of the list. I'm just getting confused with my list boundary stuff, and I'm wondering if it would be easier to just add a 0 to the beginning or end of the list, since that doesn't change my answer. It does change my answer, because then I might say my answer is 0 when it should be negative. Okay, so let's just handle our edges better. So when you have 3 numbers and they're all negative, you start at 0, 0, 0. You do not go into this case. You do go into this case because your end 2 is equal to your start. So start end 2 one farther, so that's going to be at 1. This is messed up. This is going to be 3. So this will never trigger. That fixes it, but I'm kind of suspicious. But I guess it looks right. Okay, once again, we're supposed to get this. 0, 0 is where we start 0, end 1, and end 2 are at 0. By the end of this, we want start to be 0, end 1 to be 1, and end 2. We actually want it to be 2 because you can slice a list like this. -4, -3, sliced from 0 to 2. Yeah. So we want our ends to be 1 bigger than I was thinking we want them to be before. You're allowed to go all the way up to len of nums. Okay, submit. Okay, this this is because we're not, like, let's get rid of this because we got to be able to correctly handle a list with only one thing in it. So let's use the test case. We're going to fail on a different test case now on the thing. Oh, I thought we would fail on the test case with only one element, but we don't have one like that yet. Okay, so starting at 0, if nums of start equals 0, and it is, so now increment start. So now start is 1 and end 1 and end 2 are 0. So we're going to go into here. Start is 1. End2 starts one higher than 1. So N2 starts at 2. While N2 is less than nums, and it's not, so this will not trigger. End2 stays at 2. End1 starts 1 before 2. While End1 is greater than start, which it's not, it's equal to start. So this doesn't happen. If End1 is less than start plus 1, which it is, then we don't care about End1, which we don't. So product 2 should be multiplying 1 and 2 in this list, which is 2. So why didn't we end up with... I must be tracing it wrong, because print start and 1 and 2. Because we would have the right answer if I traced it properly. We never get here. We never get here. So we start... Oh, is it because of this -1, which we shouldn't have anymore? Yeah. Okay, submit this. Come on, man. The edges of the list are just killing me. Use this test case. Put some print statements. So we expect our max to be when start is 2 and end2 is 3. So that's here. So start is 2, end2 is 3. If nums of start equals 0, no. If end2 is less than or equal to start, oh, now this is +1. Or actually, it's just if it's less than start. Because now we want... No. It is... Wait, I guess maybe it has nothing to do with that. Let me go back to... So 2 and 3 is what I care about. If end2 and I guess that's happening in here. Oh, I'm changing the products, but I forgot to take a max here. Best equals max of best product 1, product 2. Okay. I know that I'll get an integer out of this division. Are you allowed to do this? Can I do like integer division equals? Yeah, okay. So here I ended up thinking that 1 is a possible answer. Um, but why? I can't tell where that's coming from. So let's print product 1, product 2 here. We are getting a 1 right here as product 2 between 2 and 3. Why is that a 1 though? Oh, no. Between 2 and 3, why is that a 1? So Python, you've got -2, 0, -1, sliced between 2 and 3, which is just -1. How are we getting 1 out of -1 here? I'm not seeing how. Oh wait, product 2 is the old product before I updated it. So I think it must be coming from over here. So let's print this again. And now we never see the -1, so it's not coming from here. Now let's print here. Okay, so now between 1 and 1, so that's the 0. We are saying that product 2 is 1. So if start is 1, we're supposed to be here. How did we end up in the else when start is 1? Right? Isn't that? Doesn't that seem impossible? Oh, start just became 1. So it's right before start is 1 that it's right before start became 1 that we got a problem. So I'm guessing it's like our product started as -2 and then we divided -2 out of it. But you should only be allowed to do that if you are, if start is if start is less than something. Like you're not supposed to divide away the last thing, the last number. So I think I want to do the same thing with end2 here. If start is greater than end2, then you're not allowed to count this product. This is the weird part. Because the other thing is, I technically don't need to do any of this, because dividing away a number will never make it bigger. The only thing that can make it bigger is dropping a negative. Which we could figure out in a faster way than like iteratively doing this. But let's... Yeah, because like I'm doing plus equals 1. Whatever. Let's just get... I think this is like our last edge case to figure out, and then we'll have the optimal answer here. So when you're at 0, 1, and you increment start, don't divide out your last number. So if start is 1 less than end, don't divide. So if start greater or equal after incrementing, then don't divide. Greater or equal after incrementing, then don't divide. Okay. Submit. Ta-da! Okay. There's definitely stuff we could do better. This whole part, I think, is not necessary. Because you can jump directly to the next negative number. You don't have to just keep trying to divide numbers. Not only can you jump directly to the next negative number, you don't have to keep trying other negative numbers after that either, because the biggest one is going to be the largest one. So it's kind of like there's a start 1 and a start 2 also. Yeah, actually, it's like another way to think about it is you take the range of numbers between zeros. Each range of numbers between zeros gives you a candidate. If the parity is even, then that's your answer. If the parity is odd, then you either push the left pointer inwards until you get to a negative, or you push the right pointer inwards until you get to a negative. And one of those will be your answer. So you can just try both. Now that I say that out loud, that sounds so much simpler than what I did. So your start starts here. Your end goes until you get to a 0. That's a candidate. Or actually, if that's positive, that's the answer. If that's positive, that's the answer. If it's negative, then one of your candidates was the one that you found along the way, the one where the left side is where it is, and you increment to the right side and you would have found it by now. The other candidate is now you increment the left side until you find it. Wait, this is actually so much simpler than what I was doing. Because then you can just keep incrementing the left side. You don't even have to skip ahead, which would be, like, you could skip ahead, that would be faster, but you could also just keep incrementing the left side until you reach, until your left and your right are both at a 0. When that happens, you increment them both and you try again. Okay, I'm writing that. That's so much simpler than this. So here's a better linear answer. Best equals negative infinity. Start and end equals 0 and 0. While start is less than length of nums. You either increment the left or the right. So if if end is less than start, or I guess if they're equal, and start of nums is 0, then you increment them both. Start plus equals 1 and plus equals 1. if they are equal, but you're not on a 0. Also, if you're on a 0, you got to consider that 0 might be the best answer. So best equals max of best and 0. If they're equal, then you push end2 to the end. So let's also have a current running product. Which will start in here. So product started as none. Product equals nums of start. While nums of end is not equal to 0, and nums of end, or I mean end is less than len of nums, you increment it. End plus equals 1. Okay. You also keep track of the product. Product times equals nums of end. Well, except for the last one. So here we can do -1. Here end shouldn't land on the 0. Sure it can. Let's just land it on the 0 because that's easier to think about, and do -1 here. Which means product should start at 1. Okay. And then at each point, best equals max of best and product. So this is while you're growing the right side. Else, you want to grow the left side. So start plus equals 1. Also, am I confusing things by trying to iterate by more than one at a time? No, because I have to know to grow the right side first. No, but I can know to grow the right side first by growing it unless it's a 0. Okay, so I'm only going to increment by 1 each time. If we're on a 0, then skip ahead. So if the left side is on a 0, then end should be equal to start plus 1. Or I think we put them at the same place. Increment start, put end there. Okay. Otherwise, start, what is this? Start of nums. Nums of start. Otherwise, nums, if end is not on a 0, and we can still grow it. End is less than len of nums, -1. Then grow it. So when we start product at 1. then grow it, which means end plus equals 1, product times equals nums of end. Yeah, so nums grows until a 0. Otherwise, the left side grows. So this means nums is on a 0, or it's at the end. So now the left side grows. And then you do product divided by equals nums of, you do that before you, so nums of the thing you just removed. And in both of these cases, best equals max of best and 0, or best and product. Here we can just say product equals 0. No, we'll do that. Let's do that inside the loop because I'm not sure how to do it otherwise. Because I don't want to grab, I don't want to set product to 0 because that's going to mess everything up. Return best. No way, right? Not yet. Still need to mess with our stupid edge cases. So at 0, 0, we're not on 0. End is not on 0 and not at the end, so end should increment by 1. Okay, if I do this first, and I go all the way up to end, then I think this okay, let's so end is always going to be an index into the numbers, which means I have to multiply the product by the new thing. The problem is I'm not starting my product at the right value, but I think I can fix that by just starting it at nums of start. No, because then I'm not starting it properly when we skip over a 0. But I could. After incrementing, if I just set my product to be equal to my new start point, okay, integer division, output 1, expected 0. This means I'm dividing out the number itself, which makes sense actually. I shouldn't do that, but I see why I am doing that. I'm starting at the first number. I end up dividing it out. I don't want to do that. I want to divide out. I do want to divide out the number that I'm removing. I just don't want to divide out the last number. So this should be elif start is less than end. then I do that. Otherwise, I'm just incrementing. Okay. Output 0, expected 2. So start as 0, 0. I do hit this case, so start is going to be 1. End is going to be 1. And 0 is one of our candidates. Then we go back into the loop. Start is 1, so we don't hit this case. Nums of end is equal to 0, so we don't hit this case. No, sorry, nums of end at this point would be 2. So we do hit this case, but we are in the last position, so we don't hit this case. If start is less than end, start is equal to end. Okay, so here, I guess the problem is this never gets into our max. So I think now we can take this best thing out of each of these branches and put it at the end, because I do want to do it in every branch. Submit. Yeah, I guess this only makes sense if there is a next number. Wait, I got rid of the best equals, I still need this, best equals max of best and 0. But I guess you do only do this thing if there is a next number, if start is less than len of nums. Submit. So what I wanted to happen is we expand, so we start with -1, we expand this to 2, we expand this to -6, and then we grow the left side. So if I print start and end, let's use the test case. It's at 1, 2. That well, actually it's at 1, yeah, it's at 1, 2 that I want to find my answer. 1, 2 is not one of the things we look at. Oh, I guess we're counting. Okay, end is on 0. Why is that? Because shouldn't we do this before incrementing? Wait, I'm getting confused now. If end is on 0, like, how do we know we didn't just put a 0 in our product here? I mean, it looks like we did, but we shouldn't. We should multiply the product before incrementing. And then when we end on 0, 0 is not in our product. It's just that that's going to mess up some of the other stuff we were doing. Print the product as well. I'd put 16 expected 12. How am I getting 16? Oh, I must be multiplying the thing with itself. Because I'm starting at this. Does this mean I could start at 1 now? And this could also start at 1? Well, you wouldn't want to... Hold on. So we start at 1. If we're 0, whatever, let's look at... Yeah, let's just trace this one. We start at 1. Let's trace one that doesn't have a 0. This one. We start our product at 1 and start and end at 0. We're going to say end is not on a 0 or at the end of the list, so increment it. And as you increment it, you multiply by product as you go. So now you've got the times 4. Then okay, so here's where I'm saying you should go beyond the end of the list because we're adding nums before the end of the list. And put this before this check so that you don't get an index out of bounds. Okay. I think it's just this weird thing that's messing us up now. So nums, so we started 0, 0. Then we're going to multiply -2 and increase our endpoint. So now we're at 0, 1. Now end is on a 0. So we're not doing this. We are incrementing the left side. But now we're going to divide the start out. So here's where I want only if you have, if you're away from the end far enough. Is that not it? So we start at 0, 0, and that generates a candidate of -2. Then we're on 0, 1. Which I think did not change our product. Then we're on 1, 1. Oh, yeah. So product should never be 1. Or I mean, it should, but if you do, you shouldn't put that in the product. Okay, I think we have to go back to conditionally doing the max. I know there's a way to not have to do this, so we don't have to do it there. And then here, we want to reset product, but we don't want to consider that as a candidate. Submit. Okay, I mean, this is way simpler to read. I don't know why it ended up being slower, maybe because I forgot to remove a print statement. Oh, I know why it ended up being slower, because we're doing a little bit more iterating. Like, we could do a bit more jumping directly to the answer, but this is just a lot simpler. Good. That took a really long time, but I'm very happy with the solution. I wonder if somebody else wrote it in an even simpler way to read. Oh, they're doing the first thing we were doing. Cool. With the first negative and the before first negative. Okay, so what's my lesson here? I think the lesson is I should have thought of the two-pointer solution faster, and more specifically, the property that's important about this is that the solution wants to be big. It wants to take up a lot of space on its left and right side. Like, it wants to grow and consume its neighbors, which means when I'm incrementing pointers, I don't have to try all of the sub-solutions between two pointers. I can just try the two big solutions. Like, I didn't say that in a way that makes a lot of sense, but I have better intuition now for when two pointers are appropriate. It's like, it's when the solution wants to be big. Then you can just decide whether to grow the left or right pointer. You grow the right pointer when the solution can be bigger. You grow the left pointer when the solution can't be bigger. And then you end up with O of n. All right, next problem. Find minimum in rotated sorted array, number 153, medium. Suppose an array of length n, sorted in ascending order, is rotated between 1 and n times. For example, the array nums equals 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times. 0, 1, 2, 3, 4, 5, 6, 7 if it was rotated 7 times. Notice that rotating an array one time results in the array shifted to the right by 1. Given the sorted array nums of unique elements, return the minimum element of this array. You must write an algorithm that runs in log of n time. Okay, so we're just doing a binary search. we just need to think carefully about whether to shrink the left side or the right side. So one stupid way to do it is you just iterate over well, you can't do this because it needs to be log n time. I was going to say you start by finding where the element rotates. And then you can use that to just offset everything in it with modular arithmetic. That actually still might be allowed because we could find... We don't know that it always contains a 0, right? It's just that it's sorted. Yeah, we don't know that it contains a 0. So we can't just search for the smallest element. So I think we just do a binary search and have clever rules about whether we're shrinking left or shrinking right, depending on where the rotation seems to be. So LR equals 0 and len of nums minus 1. While L is less than R, we either shrink the left side or the right side, and then at the end we return... What are we looking for exactly? Find the minimum? Find the minimum. We're not looking for a specific thing. Okay, so binary search is not the way to do it, or not obviously the way to do it. Well, it still kind of is the way to do it, because it's like let's do it in a recursive way, just because then I am going to be able to think about it more clearly, but then we can switch it to not be recursive. So if len of nums equals 0, equals 1, then the minimum is the first number. Otherwise, the minimum is the minimum of the left and the right side. Well, yeah, this is clearly going to be O of n. Or worse. But you can... you can do log n because I don't have to search the left and the right side. I can search only one of the sides. So this will be log n. So find the midpoint. Mid equals len of nums over 2. And then what you want to do is check basically, you want to know if the rotation is within this box. So if nums of 0 is less than nums of -1, then you know that this one is sorted. There's no rotation within this box. So just return the left side of it. if the right side is greater than the left side, that means the rotation happened. No rotate. Well, yeah. If the right side is greater than the left side, so LF nums of 0. It said they're unique, right? So they can't be equal. So if the left side is greater than the right side, that means the rotation happened in between. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever. And then we rotate it. So this goes to here. That's going to mean, so if there's a rotation, the left side must be greater than the right side. So at that point, you take the mid and you return find min of the left side. So nums up to mid. Return min of these. And starting at mid. So the reason I claim this is log of n is that one side is always going to be O of 1. Whichever side does not include the rotation is going to be O of 1. And then the other side recurses up to, it halves each time, so you end up doing log of n overall. I think this is because I'm ending up with, because I need a -1 here if I want to split them evenly. How is the list out of... How am I ending up with a list with no size? Let's Python. I've got 1, 2. Yeah, so L equals 1, 2. Len of L -1 is 1. That divided by 2 is 0. Oh. No, but that's right, because then if I take L up to 0, oh, that's nothing. So what if I didn't do the -1? Then L up to 1, and then L up to L starting at 1 + 1. Oh, don't do the +1, because then I'm skipping elements. This is what I want. And I don't want the -1 here. Perfect. It's cool, right? This is a cool one. Next question. Number 154, find minimum in rotated sorted array 2, hard. Suppose an array of length n, sorted in ascending order, is rotated between 1 and n times. For example, the array nums of 0, 1, 4, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 4 if it was rotated 4 times, or 1, 2, 3, 4, 4, 5, 6, 7 if it was rotated 7 times. Notice that rotating an array one time results in the array shifted to the right by one. Given the sorted rotated array nums that may contain duplicates, return the minimum element of this array. You must decrease the overall operation steps as much as possible. That's a weird caveat. That's already what we're trying to do in every question. All right. I guess I don't immediately see why the solution we came up with to the last problem wouldn't work. So let's write it out. If len of nums equals 0, or equals 1, return nums of 0. If the first thing is less than the last thing. Oh, okay. So I see why this won't work. Then you return the first thing. To do, what if there is a rotation here, but the first and last element got are duplicates? And then the thing we were doing before is mid is len of nums over 2, and you return self.findMin of the first half of the list, nums up to mid, of the second half of the list, so nums starting at mid, and whichever one of those is smaller. So this is still correct. The trick we were relying on here is that we know that one of the sides of this recursive call is going to be O of 1, whichever one does not have the rotation inside it, which leads to log of n in total. I guess that's the other thing, is that's if slicing a list can be done in O1 time, which it can't, which it isn't the way I'm writing it. But that's easily fixed by taking passing in an index instead of a slice. Anyway, actually, it also depends on what Python does internally. I don't actually know how it deals with slices. Anyway, the problem here is with this example. So in this case, nums of 0 is less than, like the first thing is not less than the last thing. And that is fair because there is a rotation inside it. So actually, does this just work? I actually am not sure why this won't work. Let's see what, oh, it just works. That's a hard? The thing that said, like, you must do as few operations as possible, is that what's supposed to be making this hard? Because we can make this, we can do the thing that makes it, that avoids the slices very easily, but that's not going to make it hard. I wonder what people's solutions do. Um, I guess I don't know why you have to care about this condition. I guess I feel like I'm already... Oh, wait. I think I see what I'm doing wrong. In this case, well, no, I still think I'm right. The thing I'm thinking is, okay, let's say the case is, let's say you have a million ones and 1 0, and it's rotated somewhere, so the zero is somewhere in there. Then the problem is, I'm not guaranteed that one side of this branch is going to be 01. Because this will not trigger for both sides of the branch in all likelihood, because both sides will have 1 on both sides. But you can't do better than O of n on the example that I just gave anyway. So I do still think this is optimal. The only thing you could do differently is use indexes, like basically do our slices manually, which I don't know if that actually helps. Maybe we can look this up. Python slice time complexity. Okay, so it is O of k. So we can do better by implementing our own slices. So let's briefly do that. Let's quickly do that. So def find min, this is our internal one, which takes a start and end point. Start int, end int. It does all this. Then we return find min of 0 len of nums. And then inside here, we don't check if len of nums. We check between start and end. Nums of 0 means nums of start. Nums of -1 means nums of end. The midpoint is start plus end over 2. And you don't call self.findMin, you call findMin. And you don't pass in a slice, you pass in our own custom slice. So start and mid, mid and end. I forgot a -1 here. I think you have a minus, yeah, because when you're doing a slice, when you're doing a Python slice, you don't include the mid element or the end element of the slice, right? And you don't include the end. Wait, but I want to include the end. How is this different from what I was doing? I think because start plus end over 2 needs a +1 or a -1. Is it +1? Is it -1? How is this different than what I was doing? Let's print start and end and see where it's getting stuck. Well, it doesn't get stuck on that one. Zero, zero. How do we even get to 0, 0? Because we're supposed to split evenly. Oh, there's no even. Wait, but here. Oh, don't do -1 because the. Yeah. It's always end -1 when you're indexing into it. Okay, well, this is theoretically faster. I think the variance of Leetcode is you just need to run it a few times before you get to 0 milliseconds. Or maybe the fact that it's theoretically faster doesn't overcome the fact that Python can do slices fast. There we go. There's our 0 milliseconds. Okay. On to the next one. Number 155, min stack medium. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Implement the min stack class. Min stack initializes the stack object. Push int val pushes the element val onto the stack. Pop removes the element on the top of the stack. Top gets the element of the stack, gets the top element of the stack. Get min retrieves the minimum element in the stack. You must implement a solution with O1 time complexity for each function. Okay. We kind of need a heap, right? We need because I think a heap is the thing. Like I think we need a stack and a heap, and because a heap is a thing that has that lets you get the minimum. Yeah, because if I just have a sorted list, and every time I insert something, I insert it in the right place, and every time I pop something that wasn't the minimum, I can remember what my minimum was, and every time I pop the minimum, I know what the next minimum was. That would work, but it would give log of n for insertions, because I have to insert stuff into the right place. I think a heap is the data structure that doesn't require log of n. That lets you remember the minimum in O of 1. Right? Or no, it wouldn't let you do that, right? Because then you could use it to sort a list. Because then you could just insert from an unsorted list repeatedly. But couldn't you use this thing to do that? Oh, one time complexity for each function. So if, let's say I had an unsorted list and I insert each thing one at a time into this. Each insert will be O of 1. And then oh, okay. You can retrieve the minimum element, but you can't pop it out. You can only pop out the top element of the stack. Okay, well then this is easier. We just need to remember which element is currently the minimum. Whenever we add something, we check if this should be the minimum. Whenever we remove something, we check if the thing we just removed... Oh, well that's the problem. We check if the thing we just removed was the minimum. If it was, then we need to know what the next minimum is. So I guess one way to do that is to have a stack of no, that doesn't quite work. I was going to say a stack that keeps track of the order that stuff was inserted and a stack that keeps track of the size of stuff. But no, you do need a heap. You're going to need a heap. I just can't remember exactly how heaps work. So it can't be that a heap lets you insert something that may or may not be the minimum in O1 and lets you remove something and lets you pop the minimum in O1, because then you could use it to sort a list. I mean, I could be wrong about that. I have to think it through a little bit, but like, let's say you have an unsorted list. And then you insert this into a heap, insert this, insert this, insert this. And then you pop the minimum, pop the minimum, pop the minimum, pop the minimum. If the inserts and the pops could be O of 1, then you could use a heap to sort a list in O of n time. That's why either the inserts or the pops need to be log of n, so that the overall thing is n log n. So how do we always retrieve the minimum element? Because the thing is, you could just remember this one is the minimum. And then as you add stuff, you just keep track of which one was the minimum. But then what do you do when the thing you've popped was the minimum? Now you don't know what the next smallest thing is. You'd have to go through the list to find the new minimum, which doesn't work. If you have a data structure, like a heap, then either the inserts or the pops have to take log n. O1 time complexity for each function. Get min is the confusing one still. So obviously the rest are easy. We can just have a stack and we can do the rest. How do we always remember which one's the minimum element in the stack? Without doing more than O1. Like, the weird thing is my instinct says you can't, but I know you can because it's a medium Leetcode problem. I don't usually have an instinct that conflicts so strongly with the obvious answer, or the correct answer. So you can't just remember the smallest thing, because then you're out of luck when the thing you pop happens to have been the smallest thing. We can't store the smallest things in a heap, because then inserting into the heap would take log of n time. I'm trying to think of something different, like store a store a queue or a stack, but it all has the same problem. I'm starting to think I don't know how heaps work, and I might have to just look up heap. Is that allowed? A min heap, aka a priority queue. Like this, what I've just said here is a proof that you can't insert an arbitrary thing in O1 time and pop the minimum in O1 time. But maybe you can insert an arbitrary thing. Well, no, you can't just pop an arbitrary thing either, because then you'd be able to pop the minimum. The inserts have to take log n. Let's reread the question, because it seems impossible. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Initialize the stack, push the element val onto the stack, remove the element on the top of the stack, get the top element, retrieve the minimum element in the stack. You must implement a solution with O1 time complexity for each function. Okay, and like there's no way for me to use this to sort a list. So let's just think more carefully about it. It's we don't have a proof that it's impossible, which is good for a question that's clearly possible. How do you retrieve the minimum in O1? So you have to have some data structure where the minimum is available. And then when you pop the minimum, oh, okay. I figured it out. Because you can only pop stuff off the stack, you only have to remember what was the minimum at this point in time, because you're only ever going back in time when you pop stuff. So we can have two stacks. The actual stack and the min stack. When you push something, if val, basically stack.append val, and then new min equals min of val and stack of -1, the last thing in the stack, which means min stack.append this thing. When you pop from both. Min stack equals, or you just pop. And then you return stack.pop. I need a bunch of self all over the place. When you get the top, when you return the top of the stack, you just return self.stack -1. And when you get the minimum, you just return self.minstack of -1. And that is it. You need a self here. You also need if self.stack, this should be min stack. Else -infinity. We can just do if self.min stack, then you do this. Else you just push. Submit. Ta-da! And I think if we submit a few times, we'll get to 0 milliseconds. This is just the variance of Leetcode. Because there's no better way to do this. This is certainly optimal. Like the only other thing we could do is have only a single stack, and in each stack we have the value and the minimum. It's the same amount of space though. We're getting better. We're getting better. This is a shame about how Leetcode works, but I guess, I don't know. There's no way around it other than to analyze the code. 2 milliseconds, we're almost there. We could try the... No, there's no point. The single stack thing's not going to be faster. This is as fast as you can do it. It would be the same. Okay, last submit, and then we just accept whatever the time is. All right. Well, we did it. Thanks for watching. Please upvote me if this was helpful. But that's it. Peace.